All right, welcome to Unit 10. This is Conics. Section 1 is going to be 10.1, Introduction to Analytic Geometry. So what are we talking about there? What we're talking about is a review of some things that you've seen before. We are going to talk about the distance formula between 2 points today. We're going to talk about finding the midpoint formula, and then we're going to put those two things together. Mainly the distance formula as well as our knowledge of slope, and determine if four given points of a quadrilateral are a parallelogram. So that's what we're going to put together for today. Alright, as you can see, here's the distance formula given 2 points. Anytime we have point 1 and point 2, whether it's A and B, or this slide you see P1, P2, doesn't matter what you call them. We have 2 x coordinates and 2 y coordinates, so that's why you see x1, y1, that's the first point, x2, y2, that's the second point. To do the distance formula, we subtract our x's and square them. We do the same thing with the y's. We're going to subtract them and square them. Add those two quantities together, take the square root, that's going to give you your distance formula. So we're going to see on the next slide here, we'll actually use a right triangle example. So really the distance formula is a derivative of the Pythagorean theorem, and you'll see that here. So really what we were given was these 2 points, 8, 2 and 17, 10. If I draw this horizontal and vertical line in here, then we have a right triangle. Given the fact that this is a right triangle, you know that a squared plus b squared equals c squared. Well, what we're really doing here is we're finding C. Now, we don't have to draw this triangle, but I want to show you that that's really what happens. If I take the 2x coordinates here, 17, that's my second coordinate, minus 8, I get 9, which is really the horizontal difference between those 2 points. And if I do the same thing with the y's, 10 minus 2, I get 8, or the vertical change in the distance. And so 9 squared plus 8 squared is 145, and this distance is really our C value, if you will, of 12.04. So when you see the distance formula, this is really a derivative of the Pythagorean theorem. Our midpoint formula, again, this should be review, and the nice thing about midpoint formula is it's pretty straightforward computation without a lot of hard things to do here. So again, we got 2 points, 12, 18, and 65, negative 27. All we have to do to take the midpoint is really an average. So we're going to add the x's, divide by 2, add the y's, divide by 2. So 12 plus 65 for x's, and 18 plus negative 27. Add those two together, and we see that our midpoint is 38.5 and negative 4.5. By all means, you can write those as decimals. That's great. If we were going to try to graph these or explain to someone where these points were, we would use the decimal, so that's fine. Go ahead and use the decimal for that, and that's going to work out fine for us. Okay, here's a slightly different example. I'm not going to go through 42 examples of finding the midpoint given A and B. You know how to do that. You can add your x's, divide by 2, add your y's, divide by 2. So I don't need to keep going through examples of that for this class. This one's slightly different. Here we were given the endpoint A, and we were given the midpoint M. What we were not given was the other endpoint. We still use the midpoint formula to do this. I know that 7 plus this second x value divided by 2 has to be 18. And I know that 11 plus our second y value divided by 2 has to be 20. So I can set up my two equations here to find point B as such. And now to solve these, I'm going to multiply by 2. So 7 plus x2 is 36, 11 plus y2 is 40. And now using subtraction, I can find my x2 and y2 coordinates. And what we find out there is that x2 is 29 and y2 is 29. Now again, I don't want to mislead you here. x2 and y2 are not always going to end up being the same number. That's just unique to this particular example. But since we found x2 and y2, we can now write point B as 29, 29. So again, that was unique to this problem. They don't always end up being the same. But again, you use your midpoint formula. In this case, we're solving for the missing point instead of solving for the midpoint formula itself. All right, hardest thing that we are going to do today is right here, and this is with given 4 points. So we have point A, B, C, and D, and I just did a very rough sketch right here. If you wanted to physically draw this out to scale, you could put it on a coordinate plane. You don't need to do that. What we're going to do is use our distance formula to find the distances of the 4 sides. And then what we can also do is we're going to find the slopes. And really, we're going to find the slopes first. So we're going to find the slope of these 2 sides of AD and BC, and then we're going to do the same thing for CD and BA. The reason we'll start with the slopes is this. If the slopes of the opposite sides are not the same, then we know we're not dealing with a parallelogram. So it really doesn't matter how long these sides are if they're not parallel to begin with. So we'll find the slopes of the opposite side, and so you'll see this. I'll show all the work here, but we're going to start to the left here. So if I take these coordinates as given and find the slope of AB, and just in case you forgot, slope formula is right here, difference in y's over difference in x's. So if I take A and B and I subtract my x's, I get -6, 2 minus 3 is -1. The slope of segment AB right here is 6. I'm going to do the same thing for CD. So the difference in the y's is +6. Difference in the x's is +1. So again, I have a slope of 6. So I know because the slopes here of AB and CD are the same, these 2 sides are parallel. I now have to verify that for AD and BC. I want to make sure that those 2 slopes are parallel. So when I find the slope of AD, I get -1/4. Same thing for BC. So far so good. Our opposite sides are parallel, and that's the first step for making sure we have a parallelogram. Next, we have to make sure that they are the same length. It doesn't matter if they're parallel if one of these sides is longer than the other. Now the good news here is we don't have to check all 4 of them. We can just check either A, B, and CD and check the left and right side, or we can do the top and bottom, because if they're equal, then the other 2 are going to have to be, considering we already have the slopes lined up here. So I'm going to do the distance formula for AB, and when I do that, the difference between the x's is 1, difference between the y's is 6. When I square them, I get the square root of 37. Same thing for DC when I use the distance formula. And so I now have enough information to verify that this is a parallelogram. The opposite sides have the same slope, so they are parallel. And I know that AB and DC are congruent. If that's the case, then AD and BC over here have to be. There's no way you can have 2 congruent sides, opposite slopes, parallel, and then not have those sides be equal at that point. So this is indeed a parallelogram. In this step, if you got different slopes, you could stop. Or in this step, if you got different answers for your lengths of sides, you can stop and then conclude no. But since our opposite sides, slopes of our opposite sides are same, and the lengths are the same here, we do know we have a parallelogram. And we've got, I believe, one last thing for today. This is a distance formula. Again, this is plug and chug. The only difference here is now they've given us variables for the x-coordinate instead of numbers, which is fine. Doesn't change what we do. We're still going to take the difference of our x's, and so if we do that, -2a minus a, and 7 minus -9. They told us that the distance here is 20, so when I subtract these 2, I'm going to get -3a, and 7 minus -9 is 16. We'll go ahead and square these, so I'm going to end up with 9a plus 9a squared, plus 256 equals 20. How do you get rid of a square root? Well, you square both sides. So we'll square both sides to get to here. And now we're on our way. We'll subtract 256 from both sides. Then we will divide by 9. And when we take the square root of a, we get plus or minus 4. And so either +4 or -4 will work for this particular problem, since we get 2 answers for the square root. So again, just because they gave us variables up here for our x-coordinate doesn't mean that we can't plug it into the distance formula and follow suit. So that is pretty much the notes here for 10.1. A lot of review between distance formula and midpoint formula. Should be able to do that. And then with the parallelogram problems, you're going to have to use slope as well, which again is review for us. So with that, now you can start in on section 10.1, and we'll see in a couple of days when we do section 2 with circles. All right, thanks.